Hi guys, this is your next video on binomial distribution. I'm going to do one problem for you today, but I did want to show that this is what you're responsible for your first assessment, which I'll let you know exactly what date that would be. I'm leaning toward Tuesday of this week, but if we have to move it to Thursday, that'll be okay. These are the problems that I want you to do on page 211. I'm going to do number 20 today on that page, which looks like this. And I'm going to walk you through number 20. If you look through number 20, you'll be able to follow along, I think, with the rest of the problems. So let's get right down to it. I'm going to post this, and the video is actually going to be called 20p211. That's how I'm going to classify the names of the different videos. So number 20 says 36% of U.S. adults favor the use of unmanned drones by the police agency. You randomly select 9 adults. Find the probability that the number of U.S. adults who favor the use of unmanned drones by police agencies is exactly 4, at least 2, or less than 6. So remember, a binomial distribution is where you have 2 choices. In this case, people favor the police department using drones, or they don't favor it. There's only 2 choices. That's what makes this a binomial distribution problem. The formula is right up here, up top. So this is the formula for binomial distribution. It looks crazy and confusing, but it's not. This first part of the formula we're familiar with from chapter 3. Then what this says is this P stands for the number of successes, or the probability of success, and Q is the probability of failure. N is the sample size that you're taking, and that's always that way throughout the whole book. X is what you're interested in, and in part A, you're interested in what's the probability of 4 people saying that they agree with using these drones. When the entire population, 36% agree, 64% then disagree. So Q is always 1 minus P. So you're going to randomly grab 9 people and ask them what they think. What's the probability that 4 of them will agree with the police using drones? So what we do is we simply just plug our numbers into this formula, and we have 9 in for N, 4 in for X. P is 0.36, that's a probability of success. Q, which is the probability of a failure, which people disagreeing with this. And we'd raise the 0.36 to 4, and the 64 to a 9 minus 4, which is a 5. Make sure you can do this in your calculator and come out with 0.227. The next part of the problem says, what is the probability that 2 or more people would agree with this? Well, 2 or more means this. Here's 2 or more. All of these. It's the probability of 2, 3, 4, 5, 6, 7, 8, and all 9 of them. The only thing that it doesn't include is the probability of 0 or 1. Nobody agreeing or just one person agreeing. Now, you would have to do this formula 1, 2, 3, 4, 5, 6, 7, 8 times and add all those probabilities together. All the probabilities always add up to 1. That's very important in a binomial distribution. So if all of them add up to 1, what sense would it make to do all 8 of these, the formula 8 times over and over again? Instead, what we could do is do the formula twice and subtract this over here, subtract it from 1. And then that would give me the the answer for this pink part right here, which is all those other ones. And that's exactly what we wrote out here. 1 minus doing the formula twice with a 0 for X. N is still always 9. P is still always 0.36 and Q is 0.64. If we use the formula, we get 9 and a 0 times 0.36 to the 0, which is just 1, times 0.64 to the 9th, plus doing the formula again with x as 1. So it's 9, choose 1, 0.36 to the 1st, 0.64 now to the 8th, because this will be a 9 minus 1. When you do this, make sure you could do it in your calculator and come out with 0.891. For the next one, part C, and you could pause this video and just try to digest that and try it again on your own, reading the problem from 211. Part C says, what's the probability that it would be less than 6? Well, less than 6 is right here. It's 0 through 5 is less than 6. So from here, from 0 to 5, this is what would constitute less than 6. And again, we'd have to do that formula 1, 2, 3, 4, 5, 6 times and add them all up. The other thing we could do is do 6, 7, 8, 9, which is 6 or more, and subtract it from 1. But to make our life a little easier, now you could do that formula over and over again, but to make our life a little easier, if you go to page A8 in the back of the book, they have a table that actually does these calculations for you. And let me show you this table and show you how it works. Now, this might be a little bit hard for you to see here because the numbers are pretty small. But what we have here is in this column we have our n's, and here we have our x's. And what we're interested in is n being 9. So if n is 9, and I'm just going to put this here to hold this page open, I'm going to look under n being 9, and then the x's that I want, but I'll have to look over to the probabilities up top. That's why this says P up top here. I don't have exactly a 0.36, so we'll have to use a 0.35 for this, and go all the way down and look for the numbers that we want. Now in our problem, we want it 0 through 5. And if we look in our book under this 3, 5, and I take this as 9, choose 0, choose 1, 2, 3, 4, 5, all the way up to this number. If I add all of these up, this would be the probability of less than 6. The probability of less than 6 is the probability of 0 plus the probability of 1, 2, 3, and so forth. The other thing that we could do is we could actually, since all of these add up to 1, I could take the probability of all these, add them up, and subtract them from 1, which is what we were looking at in the problem. So you look at page A8 and look it down here and make sure it makes sense. We use this table instead of using the formula when there's too many numbers to do, and we'd have to do the formula over and over and over again like this one. Some of them get even bigger, like n could be 15 or 20, and you wouldn't want to do that. You'd want to use the table in the back of the book to do the formula for you. However, you are going to have to know how to use the formula and look through these. Another good example to look at is the very first or maybe the second example in the book. And it really walks you through how they came up with this formula. This is right here. And I would suggest that you read both of these methods. We use method 2 because who wants to make a chart and do all this work? But this is a really good example to look at and to study through and make sure you understand this. But we use this because it's so much shorter than doing it this way. But this